Hello and welcome back. Today we're going to look at the trigonometric form of a complex number. So just like we can graph real numbers on real number lines, we can graph complex numbers with complex planes. So that means that we have one real axis, that's going to be our horizontal axis, and then we have an imaginary axis as our vertical axis. So if we have a coordinate a plus bi, well, the real part is a, and the imaginary part is b. So we can graph that on the number line. And you can see right here, if this point is 3, 1, it must be 3 for the a and 1 for the b. So that's 3 plus I. And if this point is 2, negative 1, then that complex number was negative 2 minus I. Whenever we want to find the absolute value of a complex number, we're really just looking for the distance. So we can always just use the distance formula from the distance between the origin and the point AB to find the absolute value. So if we're going to plot this point, negative 2 plus 5i, the real part's negative 2. So we're going to go to the left negative 2, and then we're going to go up 5. Let me graph that correctly here. So that's going to be negative 2, 5. And if you want to find this distance, we just have to use the distance formula. So negative 2 squared plus 5 squared. So that's 4 plus 25. So the absolute value of z is going to be equal to square root of 29. Okay, everybody knows that. Okay, with the distance formula, so that's good. The next part is we're going to actually rewrite the complex numbers into trigonometric form. So when we use trigonometric form, it actually does help us with some operations we're going to get to later. But let's first practice finding how to write them in trigonometric form. So if we have the point, we're going to find the angle just like we usually would, right? We have the tangent of b over a, and we already have theta here, so I'll just leave it like that because this is the reference angle here. And if we want to find that angle, we just take the inverse tangent, right? That's easy, we can figure that out. And then if we want to find the radius, or we could say the modulus of z, well, we just have to use the distance formula, right? So that's going to be the square root of a squared plus b squared. And then when we consider those values, well, that a value, this a coordinate, is going to be the radius times the cosine of theta. And then the b will be equal to the radius times the sine. So if we write that as a plus bi, well, we could factor the r and just rewrite as z equals the radius times cosine of theta plus I times sine of theta. Remember, the r again is the modulus, and the theta, the angle, is the argument. That's like the old terms of argument. And so we can write them in degrees or radians. Okay, so let's look at this complex number, negative 2 root 3i. So again, you know that that's going to be in the third quadrant, right? Let me just sketch it right here. That's going to take us here, right? So we know that this x coordinate is negative 2, the y coordinate is negative 2 root 3. You can start to see there's a special triangle there, right? So we know that this angle right here has to be 60 or pi over 3. So we can write this angle as 240 degrees, or in radians, 4 pi over 3. So that's the argument. Now if we want to find the radius, when we can use the special triangles, we know that this is 2, so this has to be 4. But to double check, you can always use the distance formula. So that's negative 2 squared plus negative 2 root 3 squared. So that's 4 plus 12. So that will be equal to 4, just to confirm. Okay, so to rewrite it, again, we're rewriting z. So z is going to equal the radius, or the modulus, times the cosine of theta, put 4 pi over 3, plus I times the sine of the argument, 4 pi over 3. Now that's in radians, or you could put in degrees. 4 times cosine of 240 degrees plus I times the sine of 240 degrees. All right, so just using our good old trig to figure that out. Now, writing the complex number from trigonometric form is probably a little bit easier. You just have to simplify. Okay, so here we have positive square root of 8. I'm just going to rewrite those 2 root 2. And then cosine of negative, as we're negative pi over 3, well, that's going to be a 60, or I should say a 5 pi over 3, right? The same. And we could rewrite this as, this will be 1 negative root 3. So we know the cosine is just 1. And we know that the sine of negative pi over 3 is going to be negative, root this here as 1/2. And then negative root 3 over 2. Let's kind of separate that. So we have 2 root 2 divided, so that we'll just have root 2. And then here we'll have I times, this will be 2 root 6. So just root 6i. Okay, so simplifying that, we just have to use the cosine of negative pi over 3. It's going to be 1 over 2, right? The sine is negative root 3 over 2, and just simplify. So a little bit easier to find the standard form than finding the complex form. Now we're going to get into why it's useful to change this complex forms into trigonometric forms. And it's actually relatively easy. Well, it's relatively easy to also multiply complex numbers in standard form, but it's relatively easy to multiply them in trigonometric form as well. So when we actually multiply two numbers in trigonometric form, the product is going to be R1 times R2 times the cosine of the two angles added together, the sum of the two angles. So the first angle plus the second angle plus I times the sine of the sum of those two angles. The quotient, very similar. We have R1 divided by R2, right? Those two moduli being divided. And then the angles are going to be the difference. So we have the cosine of the difference of the two angles plus I times sine of the difference of the two angles. Okay, so here we're going to practice using those formulas. So we have Z1 and Z2, those two complex numbers. We're going to find the product. So we just multiply 2 times 8, which is 16. And then we're going to add those two angles. So we have to kind of make a common denominator here, right? So that's going to be 4 pi over 6, 15 pi over 6. And that's going to reduce to 5 pi over 3. And then the angle I times sine of 5. This will be the same angle, right? 5 pi over 3. And that's the angle we actually just did in the last problem. So we know that that's going to be 16 times 1 half plus I times negative root 3 over 2. And then we have 8 minus 8 root 3 I. All right, to simplify. Now let's look at the quotient. So if we're going to find the quotient of these two complex numbers, we're going to divide 24 by 8. So Z1 over Z2. So that's going to be 3. And then we actually subtract the angles. So 300 minus 75 is 225. And so we're going to have the cosine of 225 plus I times sine of 225. And we can simplify that really easily. Remember, that's in the third quadrant, so both of these are negative. So we write this negative root 2i. And then to simplify that, we'll just have negative 3 root 2 over 2 minus 3 root 2 over 2i in standard form. So pretty easy. All right, so that's it for today. I hope this lesson was helpful, and I'll see you all in class.